plug in for y when I plug in xv?
Yeah, so first you solve for dy over dx,
Yeah.
the differential equation. So you move this over there.
Yeah,
You get minus
that.
dx, divide by y squared minus x squared. And since this is degree 2 and this is degree 2, the numerator and the denominator has the same degree, you introduce the substitution y equals xv.
Yeah.
Okay, and you're changing the equation from y dependence to v dependence.
Yeah.
So now you figure out the derivative of this using the product rule. You're there? So dy over dx is product rule, derivative of x is 1 times v plus x times the derivative of v is dv over dx. And then you plug this back into the differential equation right here. And if we do that, we replace every y with xv and the dy over dx with v plus x dv over dx. Equal minus x, so this becomes minus x squared v over x squared v squared minus x squared.
Yeah.
And so now this is a differential equation in x and v. You just have to solve it. This is first order.
You can cancel the x though.
Yeah, you could cancel the x squares. Exactly, that's the point. And solve whatever you have left. Separation of variables. Or integrating factor method, depending on what we get.
This looks like
So
a,
this
would just be a u substitution. So there's a du over u.
What do you mean by u
Because
substitution?
there's just the top is the derivative of the bottom. It's half the derivative of the bottom.
You're not separated yet. You still have v and dv on the left.
Oh, right.
You can't just integrate. So this is over v squared minus 1. So you have to work it out from here. So you have to move the v onto the left, to the right. This is basic calculus. dv over dx equals minus v over v squared minus 1 minus v.
dv over dx.
When you take the derivative of y, because y is function of x and v, okay, the derivative of v is not 1, it's dv over dx, because v is the dependent variable. So you do get dv over dx from the dy over dx term.
Right.
Yeah, and so now we can just simplify the right hand side. Common denominators, v squared minus 1, so this becomes minus v minus v cubed plus v. If I multiply, because this is over 1, so I multiply this here and there by v squared minus 1. What?
Wait. Oh, right. Never mind. It's, this is dv dx. I mean,
So
dv.
these two
dx.
cancel. Yeah, and we get x dv over dx to equal minus v cubed over v squared minus 1. Now what we can do is multiply the dx on the right hand side, and so we have to separate the variables and divide both sides by this. So I can put the dv with the v, the x with the dx. So I'll do all this in one step here. Equals dx over x. And so finally here we will get v squared minus 1 over v cubed. Oops, I'm going to introduce this. dv equals dx over x. And now that the variables are separated, we can introduce the integral. We can integrate both sides. So here this will just be minus 1 over v minus v to the minus 3 dv, because 1 over v cubed equals ln x plus c. And so if we integrate both sides, we will get uh, integrate both sides, we will get minus ln v plus v add 1 minus 2 over minus 2 plus ln x plus c. Um, and so now we will get minus ln v minus 1 over 2v squared equals ln x plus c. And what's our substitution? Y equals xv. So now we could plug in y equals xv back into this. Technically, this could be an acceptable answer for the first one. We just need to modify it. So we have minus ln y is equal to xv. So that means v is equal to y over x. So y over x minus 1 over 2 x squared over y squared, because this is y squared over x squared in the denominator, yeah, equals ln x plus c. And see here, we can put these two ln's together. Let's put them apart. So this is minus ln y plus ln x minus 1 over 2 x squared over y squared equals ln x plus c. And the reason I did that so that I can cross out these two terms here, and then we will get if we continue this, we will get ln y equals, I will move ln y to the right hand side, equals minus 1/2 x squared over y squared plus c. Minus c is just another c, so you will get y equals e to the minus half second here. Okay, yeah, so minus half x squared over y squared plus c. Everything is correct. So we can split this e into e to the 1/2 or e to the minus x squared over y squared. So we can make it obvious the dependence of y on the differential equation in terms of the variables times e to the minus 1/2 oops, times e to the c, and there's a 2 here, or second, yeah, I think it's correct. So minus 1/2, there's a 2 here, e to the c. E to the c is just another c, so we can rewrite this this is just another c, so I can rewrite this final answer as y equals technically this was an absolute value if you want to be really specific about this. So this answer will need a plus or minus. So plus or minus c e to the minus x squared over 2y squared. This would be the final solution to the differential equation. How are we doing on that, Ben? You got the idea?